Hi, here's my presentation for Lab 2, which is the charge tape revisited. So to get started, the purpose of this lab is with two pieces of charge tape, compare the point charge model to the line charge model. The line charge model is achieved by treating each segment as a point charge to get a more accurate measurement of charge distribution for the tape. Now for our assumptions here, we have no air resistance, tape has an even charge distribution, each piece of tape has the same charge, and the tape is treated as a rod. So going a little deeper into this, instead of treating A as one charge and B as another charge, we are instead replacing A with a bunch of charges down the line, and the same thing goes with B. This gives a little more accurate because we're not just concentrating the charge in one specific spot. Now to get started, back to our lab 1 results that we will be using, the measured distance between the tapes was 0.002 meters. The mass of tape B was 2.03 times 10 to the negative 4th kilograms. The length was 0.2 meters and the width was also around 0.02 meters. Now the tape is also noted to be positively charged since it repels off human skin, which is also positive, and since like charges repel, we're going to get that representation we see there. And then for our computational model, where we did treat it like a point charge, here are the values listed below. The important thing to note is the charge itself, which is 1.9 times 10 to the negative 10 coulombs. That will come up later when we compare it against the line charge. Now for the physics principles we're applying here, we have, like we normally do, Coulomb's law and the force of gravity. Force of gravity is important because that's what's going to basically settle out our equations and what we're going to set the force of the line charge equal to equal that out. And then Coulomb's law, as usual, it's a core principle here. But what we're adding is the electrical field of the rod. This is very important because this is what defines this entire computational model. Instead of treating it like a point charge, we're treating a bunch of little charges down the length of the rod. You can see that length is incorporated into this model. Now let's get into our computational model. To the right, it's pretty simple. It's the iterative process across the charge to demonstrate the little charges across the tape. So we're getting that line charge instead of just a point charge. And to the left, we see the Q in the first line, we see the Q used for the line charge instead of the point charge, and then applying that to get the force of the charge itself by, as usual, just multiplying the electrical field by that charge. And then we also have a good old gravitational force that we're going to set that equal to, because we're not accelerating at all, we're static. So those can just be equal to the force from the line charge and then the force of gravity. We also have just the electrical field below. And then this is what we get for our computational model. You can see it right there. And then an important thing to note is how much we varied from our point charge earlier. So the difference is 3.99 times 10 to the negative 9 from lab 1 with our new Q value of 4.18 around times 10 to the negative 9. This is a drastic change, and let's see why we get that.